All right, thanks. So we can get started. Hello, everyone. My name is Mesut Durukal. I'm a quality assurance automation engineer. And in this session, we will a little bit talk about measuring the quality. I find quality assurance term itself a little bit assertive, like I'm ensuring the quality, everything is perfect, so we can go out to production. It's too assertive, right? It's too idealistic. It doesn't sound too realistic. But let's see what we can do, how we can measure the quality and how easy or how difficult it is. First of all, can I understand the participants? Like, are there any developers in the room? There are quite a few. Are there any testers? Great. This is the correct answer, right? All developers should be testers as well in the meantime. Are there any Scrum Masters? Oh, this is more. And I assume the rest would be some Agile practitioners. So all of us somehow are involved in the Agile practices, right? We are doing some development practices, testing, or somehow related to the Agile practices. And let me ask one more question. Is there someone who is trying to measure something? It can be anything, like measuring the progress we have done, or maybe the bugs we have found, maybe the features we have completed. I saw a lot of people measuring something. Are there anyone who wants to share what they are measuring? For example, can I ask you, please? What are you measuring? Yeah, you, please.
Ah, ah. 進捗と、バグの数とバグが直されるまでの時間を測ってます。
Great, awesome. Are there anyone else who is measuring something else? Please. If English, I think I can just repeat.
Yeah, I think it's pretty critical. Yeah.
Oh, yeah.
So I measure engagement mostly. So how much of the features are actually used, how often they're used, how often people come back. So more outcome-based metrics. Also some code-based metrics, more like the more static analysis kind of things.
What kind of metrics do you use?
How long people take to sign up for our service, how often they come back, how often they correct things in the system that they once placed there. So as a proxy to usability, so basically data quality, those kind of things.
I see. Thank you so much.
Yeah.
Thank you. So thanks a lot for sharing. And I will share some metrics as well, but we will discuss how useful it is. Why are we doing these measurements? Why do I have to count the bugs? Why do I have to check the numbers signing in or coming back again? Why do I do all these kind of things? Let's see, let's discuss the details. So what we will go over is, after a little bit introduction, we will go over some metrics, what kind of metrics we can collect. And then I will share some practical application in my actual projects. I have done some practical application. So I will share how it went and what kind of preparations I have done and what kind of metrics I have collected and what was the outcome I will show. And finally, we will summarize the session. So let's start with the introduction part. Let's a little bit discuss more on, as we briefly discussed, why are we doing this and what is the purpose? What is the meaning of these measurements or the monitoring activities? Even in real life, we are doing some measurements, right? For example, I'm measuring my weight. Like recently I gained a lot. And every day I'm going on the scale every day, and I'm trying to measure if I'm going even higher or lower. Or even when I'm driving, when you are sitting in the driver console, you see a lot of metrics in front of you, right? You can see the gas level, the oil level, the air pressure in the tires, the temperature levels, lots of different metrics. But why do we need them? Because let's think you don't have them. Let's think the system is broken and you don't see all these numbers, all these metrics. So you don't know what is the gas level, right? What is the oil you have? You might not know how much more you can go furthermore. Or if you need to fill in your tank or not, you don't have any idea because you don't have all these numbers. But when you do this measurement and the monitoring, then you have some idea, like how much you already went because you measure the kilometer you have done. And then you measure the oil consumption, the gas consumption. And then with a projection, you can estimate how much more you can go. Now we are talking about a feature projection, right? It's not only about collecting the numbers from the past, but also to a linear projection to the future. So we will talk about covering both the past and the future. This monitoring activity should bind the current collection of metrics to the past artifacts and the future estimation. So let's see how we can do. First of all, we have to prepare our environment, right? Because if we try to collect some metrics, of course, our environment, the working environment should be visible. I should be able to collect some metrics. If I cannot do the measurement somehow, due to some reasons, then I will not be having all those data. So my environment should be visible and informative. If the numbers or the metrics that I'm collecting are misleading, then I will be going in the wrong direction, right? Those data will be misleading for me. What am I talking about? Let me share a funny scene from a movie. I'm originally from Turkey, so this is from a comedy movie from Turkey. Please take a while and try to understand what's happening here. The story is, one commander is trying to pick someone, one soldier, to send to the enemy lines. And what he says is, one brave person, please, 3 steps ahead. And then he turns behind. While he turns back, he sees one person. And what happened there is actually everybody stepped 3 steps back, and only one person was there, which was the most stupid person in the army. So he was selected, and the commander sends him to the enemy lines. And of course, his mission is, it's a very dangerous mission, and his mission is just watching the enemy lines. And at some point, the commander is calling him and asking, where are you? And he's saying, I'm in the middle of a jungle. I'm in the middle of a very crowded forest. Because he has some camouflage, right? He doesn't see anything else. But when it zooms out, we can see he's in the middle of a desert, actually. Just because of his very narrow view, he thinks that he's in the middle of a jungle. But normally he's in the middle of a desert. So the idea is instantaneous captures might be misleading. We should be concentrating on the big picture. If we concentrate on a very narrow view, like I collect a few metrics, only a few days, and then I have an idea about my progress. That a few days measurement might be misleading, because why don't we measure the whole month, the whole year, right? So the instantaneous captures might be a little bit dangerous. Again, the main idea is binding what I have now to the historical artifacts and the future estimation. Because otherwise, if I collect only instantaneous metrics, like I have 10 bugs found in the sprint. What does it mean? Finding 10 bugs does not give any idea, right? I have to bind some other historical artifacts. What was the number in the previous sprint? What was the number in the maybe the last 5 sprints. So I need some historical artifacts to construct some meaningful outcomes. And in this way, I can answer some questions. Like, how long will it take to test? Now I'm talking about a feature estimation, right? How long will it take? How can I know? First, collect some historical artifacts, like with this resource, with this scope. Normally it was done in this time. But now I have this resource, I have this scope, so I can guess, I can estimate how much will it take. We are doing an estimation, we are doing a projection. And there are lots of different questions we can answer. Those can be both the future projections or questions related to our past activities. How did it go? What kind of outcomes did I have? Those kind of questions I can answer. And not only answering those kind of questions, but also I can do further implications. Like at this point, do I need an action item? Like I checked and I did a projection and I checked if I can conclude all the testing activities in the next sprint, right? This is a feature estimation. And if I realize that I cannot, because normally with the same resources for the same scope, it took 3 sprints. And now I'm trying to check if I can finish this in only 1 sprint. So normally with a linear projection, it's not possible, right? With the same conditions. Of course, there might be some slight variations, but more or less, if it took 3 sprints, within 1 sprint, most probably it will not be possible. So at this point, I can understand I have to take some action items. What can I do? Maybe add some more resources, or maybe cut it out some scope, right? Do a prioritization and go with the most important functionalities. Otherwise, you cannot complete everything. So monitoring can be very useful. But if I do the monitoring itself, like I'm trying to lose some weight, right? And every day I'm going on the scale and I'm measuring my weight. It didn't change, or it didn't, maybe it was even higher. Why? Because I'm not doing anything to improve it. I'm just monitoring, I'm just measuring, and I realized that it's not going better. So monitoring and measurement itself will not work. We have to collect a lot of data, and we should be able to interpreting this, analyzing this, and deriving some action items, deriving some continuous improvement ideas. Otherwise, again, monitoring. You can report to your managers like this report. I have a lot of numbers. We can have lots of different collections here. And then the main question would be, and then what? How can we use these numbers, right? What is the outcome? What is the result? What should I understand from this? The key point here is just taking some action items. Read the numbers, read the metrics, understand them, and try to derive some action items. So this is a summary of the first part. First of all, prepare your environment. It should be visible and informative. And then after collecting these numbers, understand the situation, read the numbers, reading the air, right? What's happening here? Am I going in the correct direction? Or do these numbers show me a good progress? Or something has to be changed? I have to understand the situation. And finally, after understanding, going over the root causes, how can I improve this situation? So monitoring itself will not do. I have to derive some action items, some improvement rules. This was the summary of the first part. Now, let's a little bit talk about metrics. What kind of metrics we can collect or measure to improve or measure the quality? So again, at first I asked, what kind of metrics are you collecting, right? These are all the metrics we can collect. There are too many. Like if we do a small workshop here, I'm sure we can collect hundreds of metrics. So which one should I collect, or which one should I concentrate on? It is very difficult to trying to manage all of them. Then what is the correct strategy? What is the correct policy? Maybe do not try to measure as much as you can, but try to collect the best ones, the ones which will help you, which will serve you to understand your situation and to help you achieve your goals. First of all, what are your goals? Is it reducing the test execution time? So this means maybe you have to collect some time-related metrics, right? Or is your goal trying to reduce the number of bugs? Then maybe you should collect some metrics related to the bugs coming from the production environment, the bugs found in the testing activities. So it depends. It depends on your purpose. So please try not to collect as much as metrics you can, but select the best subset of metrics. How many of you know Cam Kainer? Does anyone know? He's a very important person for the software testing activities. He's the founder of the Association of Software Quality Assurance Foundation. And he's one of the first people who introduced the exploratory testing activities. So what he suggests for a decision criteria for selecting the metrics is, these are the features for the metrics you are collecting. For example, it should be correlated. Like if you collect some metrics which are totally irrelevant from each other, then maybe it doesn't make too much sense, right? They should be correlated with each other and they should be consistent. Because once, if they are giving some progress in one direction and once in another direction, it means it is not consistent. And it should be easy to track. It should be predictable. And it should have some discriminative power. Like, I should be understand if something belongs to this group or something belongs to this group. It should be discriminative. Otherwise, if I cannot understand anything about the category or of a feature, like is it good or bad? I don't know anything because it doesn't have any discriminative power. And finally, the reliability, of course, like the number of bugs, right? Does it really give me a understanding of the quality? Like the number of bugs are increasing. Does it always mean that the quality is going worse? Maybe not, right? Or the number of test cases, for example. Most of the cases as developers, we try to catch some metrics, right? For example, 80% coverage. Is it reliable? Like the number of tests, okay, I had 80 or let's say 70% coverage. Then I tried to hit 80% and I added some test cases and now I have the 80% coverage. Is it reliable? I add some test cases, but are they really good tests? Like, do they have ability to catch the bugs, catch the vulnerabilities? Sometimes just the number of tests, just the quantity does not help, right? I need quality on top of quantity. Not only the number of tests, but also the capability of tests to catch the bugs, to catch the issues on the software. But again, how can I select my metrics? What kind of quality metrics I can select? Maybe I can align my quality assurance metrics with the product metrics. What kind of quality product metrics do I have? First of all, what are we trying to do? Of course, we are trying to improve our confidence, right? We are providing the good product for the customers. What is the definition of a good product? Is it really meeting the customers or the client's requirements? What do they require? And what am I giving to them? This is the correct. product. On the other hand, I'm trying to do this very fast, right? Fast delivery. And not only the new functionalities or the features, but also sometimes I'm having some bugs. So I need to deliver the hot fix or bug fix to the production environment. Otherwise, the bug will be there until I solve it. So these actions should be very fast. Okay, these are my purposes. So as a quality assurance member, what kind of metrics can I collect? They should be aligned with these metrics. Like, what was I trying to do? I was trying to deliver fast, right? So my tests, are they supporting this fast delivery? Like early feedback? Or it is even slowing down? Like if you listen to the keynote in the morning, there were several similar topics, right? The test, like I added lots of different tests and they are trying to catch if there are any regression issues, but it's running in 1 hour. It's not acceptable, right? Whenever I change something, I don't have to wait for 1 hour. It should be completed maybe in minutes or if possible, even seconds. What he showed it was completed in 10 seconds, I guess. So it shouldn't be slowing down the pipeline. It should be supporting the fast delivery. And it should be supporting improving the confidence. Like I added several test cases, but is it really improving the confidence? Like I run my test cases, so I'm very confident. Okay, I don't have any bug. Can you say this? Can you rely on your test cases? How can you understand is there are lots of different approaches. You can do mutation testing. You can intentionally inject some bugs to understand if the test cases are capable of catching those issues. But again, I will repeat myself a few times, but not only the numbers, not only the number of test cases or the coverage, but also the quality of test cases. It doesn't matter thousands or hundreds of test cases you have, but it matters how many critical bugs you have. If your thousands of test cases missed one critical bug, then all your testing activity will not be counted in a good manner. It will be questioned all the time, like, are these test cases really reliable? Or do we really need them in our pipeline? They're already slowing down the pipeline. One example, we always talked about the theoretical collections of metrics, but this is just one practical example. Like you can construct this set of metrics. I will try to have a coverage of 90%, at least for the critical features. Again, for maybe very less severe features, you don't have to cover all of them 100%. You don't need. Do a prioritization. Try to understand the most severe, most critical features. And then you can collect some metrics and try to continuously monitor them. And you can, for example, try to understand what's your false failures. This is also important, right? If you are talking about reliability, it's not only catching the bugs, but also when it fails, is it a real failure? The test fails, okay. But normally the feature was working as expected. It's not a real failure. It's a false alarm, right? It's also very important in terms of the reliability. So let's talk about some metrics in different categories. Some of them are related to the time, like mean time to failure, mean time between failures, mean defect resolution time, or there can be lots of different metrics which are related to time, like mean time to implement a feature, mean time to merge a new request, anything related to time. This you can measure, right? There is the unit of time. It might be seconds, it might be units, it might be hours. There is a unit for time we can measure. How about cost? Also for cost, we can measure. There is a unit. I can measure in JPY. How much did I spend? Or I can count in dollars, US dollars. I can count in euros. There is always a unit for cost. I can count. This is also not relatively difficult, but you can guess what is more relatively difficult, which is quality. In the first place, you don't have a unit for quality, right? We cannot count in seconds, minutes, JPY, US dollars. How much quality you have? You cannot say in numbers, right? You cannot collect the metrics. Well, of course, there are, again, different things you can do to have an idea. Again, it might not be only a single metric, but by collecting lots of different things and integrating together, you can have an idea and understanding of your quality level. For example, we are always talking about bugs, right? Bug is a good example for showing the level of quality you have. For example, this is on the left-hand side. Again, this is an example from my project. What we did is we collect several metrics across bugs, like the service on which the bug was found. For example, 50% of the bugs were found on login feature. Or let's say 60% of bugs were found about signing out feature. If you do this kind of monitoring, like you have, let's say, 50 features, and for only one of them, the 50% of the bugs were found on that specific feature, then you can already guess something is wrong on that specific feature, right? You can talk to the relevant team. What's going on here? Because most of the bugs are coming from this feature. Maybe they are skipping the testing activities, or maybe they are doing the wrong configuration. So you can already have some understanding on specific parts of the product. Or you can show the percentage of severity of the bugs. Like most of them were high severity, or very few were in high severity. Mostly we are finding some cosmetic bugs, less severe bugs. If that is the case, we can try to focus more or finding more functional bugs. So you can still have some useful outcomes from this kind of monitoring activities. And on the right-hand side, the diagram shows the escaped bugs. Escaped bugs means the bugs which were not found during your testing activities, but they were escaped from your activities, your testings. So they went to production, they were reported from production environment. So which means it was way slower feedback, right? If you already found it in your testing activities, it would be already an early feedback. But if you cannot do it, if a bug is escaped into production, then it will be going through a lot of stages and it will be a slower feedback. How about inner quality? Again, it was also covered in the morning keynote, right? What do you understand from the inner quality? Inner quality is, it is not visible from outside. Like when you ship your product to the customers, maybe they will not be aware of these kind of issues because they are mostly related to the code issues. Maybe you have a lot of complexity, you have some maintenance issues, you have some technical debt. All these kind of things are inner quality. They will not be seen or visible by the customers or the users, but it will still affect your development or deployment activities. Because again, you have a technical debt, you have to fix it. And if you have a lot of technical debt, if your code is not easy to maintain, then the feature activities you cannot complete very easily or very fast. These kind of maintainability issues will slow you down. So inner quality is also an important part that we should have an eye on. Moving on. Last, but definitely not least, emotional metrics. It's also very difficult to measure, right? How happy I am. Like I'm working for this product. I'm in this project group. But am I really happy? Or I have some complaints about my team, about the product that we are producing, or that we are developing. How proud I am of the product that we are giving to the customers. Or are we capable of keeping the organizational culture, team know-how? All these kind of things are examples of emotional metrics. Again, it is not easy to collect, but please try not to forget this. Because products will go, products will change, but you will have people with you all the time. If people are not happy with what you are doing, how you are doing, then after some time, they will somehow try to disappear. So the summary of the second part. This time, we talked about metrics, right? The first part was the preparation of the environments and the benefits of measurement activities. This time, we talked about what kind of metrics we can collect. And the very short answer is, I cannot tell you which metrics are the best for you, because you have to analyze what is your requirements and what is your goal. And then you can define a subset of metrics. Because if your goal is trying to reduce the time of implementing a new feature, maybe counting the bugs might not relate that much, right? It is not related to too much on the effort of implementing a new feature. Or if your purpose is executing the test cases as much as you can, like increasing the number of test cases, then counting, again, the counting bugs might not be too much related. So first of all, define your goals and then try to select a subset of metrics. And then you can categorize them to better manage or easily manage them. Let me share you one practical application, what I have done in one of my projects. First of all, the very first step was customizing my environment. What we talked in the beginning, prepare your environment, right? In this case, what is my environment? For a project management tool, I'm using Jira. So by using the API of Jira or even the UI, you can do some customizations. Like normally the default flow is, how do the issues start? They start with new, right? New status. And then in progress, and then maybe pending for review and complete. 3-4 status. In this life cycle, I have almost 10 different status. Why am I doing this? Because I have to monitor all individual single steps. Like in my test lifecycle, after starting, after I mark a test case as new, then I start working on that. Now, first, I try to review the steps. So it's under review. And then, if there is nothing wrong, then it means it is executable, at least manually. Then I try to understand if I can automate this, I can implement. Then I start coding. So it is in the implementation status. And then after I complete my code, I send for a peer review. It's under code review status. So I'm increasing the resolution, right? In every individual step, now I can understand how much time did I spend. Otherwise, if I don't do this, all this customization, if I do only have new, in progress, done, then I can understand how much time did I spend on in progress status. But when I'm saying in progress, it is reviewing, coding, implementation, code review, or merging the code. Which one? So I don't have enough resolution. So first do the customization. One more example. You can add several custom fields. for your tracking on your entities. Like, for example, on the right-hand side, I think it's an example from GitLab. So for every merge request, you can mark when it was merged and when was the merge request created. So you can understand how much time did you spend on the merge request itself, the merging process itself, right? You know when it was created and you know when it was merged. So you know the time in between. And on the left hand side, it's a example from a test management tool. It can be like X-ray or TestRail or any other test management tool. So you can add some custom fields. Like in this case, I added the average test execution duration. After I execute a test case, I know from the test framework the time I spent on this execution of this test case. And then I upload automatically to the test management tool. In this execution, the duration was 3 seconds. And then in the next execution, it took 5 seconds. And then in the next one, it took 2 seconds. So each time I'm uploading the results to the test management tool. It's not manually done. It's automatically done from the code. So in this case, you can keep a historical artifact. At some point, when you go and see all the historical artifacts, you can see all the average numbers for this average execution duration. And then we already briefly discussed about this, but doing things automatically instead of trying to do everything manually. Like all the queries you can do on Jira manually. Every day you can go and use Jira UI to perform your query, right? But you can also do automatically as well. Just write a script and you can run this on a job every night, for example. So when you go to the office in the morning, you will already see the results collected by the code. And finally, of course, I'm collecting all the results, I'm seeing all the results, but I don't want to lose them. So I keep them somewhere in a cloud service or somewhere, just keep them. This will help you to have the historical records. And finally, numbers are great, but it is not easy to read the raw numbers, right? So use some dashboards or charts. Reflect the numbers into the charts so that you can easily understand if the trend is going higher or lower, or you can set some boundary values, set some limits, right? And if limits are violated, then you can be alerted. You can send some notification. For example, if the response time exceeds, for example, let's say 20 seconds. After 20 seconds, page is still loading. So the response time is very slow, right? So your limit is, let's say, 15 seconds. After 15 seconds, then the system can already send some notifications to your Slack. It can send an email, it can send an SMS. You can somehow get some notifications or alerts if it's a safe critical system. So this was the last part of the application. Automatically collect metrics and then reflect them into some charts and dashboard to easily understand the situation in your environments. So the summary of this last part is, first of all, customize your environment. Please try to make it visible and transparent. Every single action or at least status phase should be visible. And then try to automate this monitoring activities because performing manually is not easy. And finally, visualize by using some charts or dashboards. Final remarks. Please be careful. There can be hazardous metrics. Like especially if you are trying to do individual performance evaluation this person found $5. This person found $20. So this person is better than the other one. Obviously, it is very dangerous, right? All this person is doing is not finding bugs. Maybe he is doing some more useful initiatives. Finding bugs is just an example, but any strict count, any individual number that you are collecting might be misleading. Please try to interpret them with the help of other metrics as well. Collect a lot of metrics together and try to understand the whole story. In the beginning, we discussed about not focusing on a very narrow scene, right? But focusing on the big picture. Because if you try to narrow your view, it might be misleading. You might think that you are in a jungle when you are in a desert. So this is a little bit dangerous. Please be careful. And again, monitoring and measurements will not do itself. Try to derive some action items. Please try to use them in your continuous improvement. Interpret them. If numbers are going lower or higher, you can try to find some ways to fix them. But again, this is just an example. There is one way to do that in a systematic way. There is one approach introduced by Walter Stewart in 1920s, which says that when you see a change in your trend, you don't have to react immediately. Please wait for a while. If you see numbers, maybe 7, 8 numbers consecutively lower or higher than the trend, then you can adapt your trends. If you see a change immediately, again, it might be an outlier. You don't have to react immediately. Please wait for a while. If it is a continuous, if it is continuously in the lower or the higher limits, then it might be the time to take some action items. So thank you so much for listening to me. And if we have any time, we can go over the questions. Ah,
貴重な講演ありがとうございます。いくつかスライドの中で、測定されている、ものを例として挙げてもらいましたが、それ以外に、この測定をすることで、とてもいいリアクションにつながったってものがあれば、教えていただきたいです。
Again, the whole idea was just finding your own metrics, right? So if I share some metrics, it might be useful for you or it might not be. So you should find your own metrics. But as a quality assurance person, I can give you some examples. Like, again, maybe not the number of bugs, but the content of your bugs. Like they are mostly the UI or the security bugs or functional bugs or what kind of bugs they are. The content of the bugs might be one thing, and then the quality of your test might be another thing. Again, not the number of tests, but the quality. How many of injected bugs can be found by your test cases? Again, I briefly told in the presentation as well, but there is an approach called as mutation testing. You can intentionally inject some issues, bugs, and you can try to see if your tests are capable of catching them or not. These kind of metrics you can use.
講演ありがとうございました。スライドの中で何個か、実際にいろんなメトリックスを測定するっていう話があったと思うんですけども、例えば、テストケースのカバレッジであれば結構比較的に簡単に測れるメトリックスだと思うんですけど、一方で、例えば、このテストのクオリティが、落ちたテストの、種別が何なのか、例えば、フロントエンドなのか、バックエンドなのか、あるいはバックエンドの中の、プロダクト A なのかみたいな、そういうなんかちょっと主観が絡むような、メトリックスをどうやって測定しているかっていうところの話をもう少し詳しく教えていただけると嬉しいです。
Yeah, I agree. It is difficult. It is not easy. It is not straightforward. I agree. But you can do, this is why actually you should take this monitoring activities into account seriously. You can do a teamwork. I have one example. For example, the severity of the bugs. It's subjective, as you told. For me, it is 71. But for another person, it's 72. Right? So what is the correct one? Is it 1 or 2? It is subjective. But what can you do is grow a systematic approach. For example, how do you define your severity? You can take criticality into account. What happens if this bug happens? Visibility, how visible? There is a critical bug, but it is not that much visible to the customers. And likelihood, it is a super critical one, but it is really super low likely to happen. It's a very rare case. So these kind of dimensions you can take into account, and by collecting this, you can grow a systematic approach. And then you can do a teamwork, like you can do voting. For me, it is 71. For another person, it's 72. 1, 2, 1, 2. And for another person, it's 74. And collect the ideas. Why do you think it's 74? And do a brainstorming. And finally, you can all be on the same page. Thank you.
It's time to finish this round. Thank you.
Thank you.